Hello and welcome to Math World. Alright, it's time for the challenge problem. This one comes from Hazel. Hazel asks, what is the value of x for 163.5 minus 16x plus 14 thirds, thanks for the fraction, equals 45 plus 231x. Alright, now while the numbers might be a little complicated, let's follow the process. Let's combine our like terms. I'm going to go ahead and try to move this x to the other side. I'm going to do that by doing plus 16x. Plus 16x. Let's reunite those x's right away. Rewrite the problem. Those are gone. 14 thirds equals 45 plus 247x. Already looking simpler. 14 thirds, I'm going to go ahead and write that as a decimal because why not? 14 thirds is really 4.67 rounded. That's fine with me. And rewrite the problem. So it doesn't hurt to turn a fraction into a decimal if that's what you're dealing with. Now I can add these up. 168.17. Yeah, that looks about right. And then the other side. Uh-oh, it's almost done. Subtract 45 from both sides. Subtract 45 from both sides. 123.17 is 247x. And lastly, divide both sides by 247. And while that will give us a weird number, we can figure out that x is now equal to 123.17 over 247. That looks like it's about almost a half. Let's use our calculator and see what the exact decimal that would be. 123.17 divided by 247. Ooh, 0.498. Yeah, it's almost exactly a half. Just under. Well, solve the challenge. As you see, as long as I follow the process, it's not that hard. Alright, want to see one a little bit tougher? This is actually a problem that I did myself earlier this week because I'm trying to buy a new car. This is a real life problem. Alright, so here's my harder problem, and it comes from a real life scenario. I'm looking to buy a new car. This is real. I found one car that cost me $300 a month. Another car cost $355 a month. Now the more expensive car had a better gas mileage, meaning it was cheaper to put gas in the car. Now I'm not going to go into the details, but I was able to figure out a slope for my gas, and it came out to be 2.5 over 47. So the slope is 2.5 over 47 per mile. I decided to make x my miles driven and my y is my cost. But instead of having a y here, I'm actually going to try to figure out when will the more expensive car be equal to the cheaper car. And I had to figure out the slope of the cheaper car. It had a gas mileage of 2.5 over 33. Which is a little bit more expensive. And we'll talk about in Unit 3 actually how to solve problems like this. But I set them equal to each other to figure out when will the cost be the same for a certain number of miles. How much driving do I have to do to make it worth getting the more expensive car? Well, here's a tough problem. Let's see if I can solve it using what we've learned. I will subtract 300 from both sides. And cross out my 300s, leaving my 2.5 over 33x. I'm left with 355 minus 300, which is 55. And here's my other slope, 47x. Next, I will want to combine the like terms, the x's. I'm going to do this by subtracting 2.5 over 47x from both sides. Now that looks like a big headache, and it kind of was. So I had to do a little bit of combining like terms and figuring out like denominators. I won't go into the exact all the work that I went into, but I did figure out what the like denominators were for this problem. I came out with a common denominator of 1,551, and after doing the subtraction, the answer was 35 over 1,551. And don't forget, this was an x. I combined those like terms. That was the hardest part of the problem. Then I got to this point because these canceled out and I'm now left with this problem. How do I inverse a fraction? Well, I just multiply by its reciprocal. So I multiplied everything by 1,551 over 35. These will cancel out, leaving x. And on this side, I have 1,551 over 35 times 55. And the answer was 2,437. X was my miles, so I figured out I need to drive 2,437 miles in 1 month just to make it worth to buy the more expensive car. I also know personally that I only drive about 1,000 miles a month, so this would be way too much. I am not going to drive enough to make it worth the more expensive, fuel-efficient car. I'm going to go with the cheaper one. Well, there's a real-life problem, and it was solved. That's it, and I'll see you in math class. Now for a word from our sponsor, Papercut Games. After that hard problem, let's try a simple game. This one is called Derby Race. This is a game actually from my childhood, and it's not really a board game. It's just a little electronic game. Basically, I'm surprised I found it on the internet too. It's so old. You have these little tiny horses, and you put them each into this little track, and everyone picks a horse. So I'll pick this yellow one here, and once they're all in there, get them all in the back and close the gate. Then you turn the game on, and it's electronic. Ready? And they're off. And then you basically try to see who gets to the end. Let's go yellow. Let's go yellow. Oh no, he's losing. Ah! Oh no, it looks like white and blue are going to win. And, oh. And orange is in third place. Well, that's it. Just an old game called Derby Race. I'm Mr. Bixby, and I approve of this message.